Welcome to the Topic Class Revision Series Day 5 walkthrough, and today's topic is probability tree diagrams. So in this first question, we're told Pratik is practicing his penalty kicks and the probability that he scores a penalty is 0.6. We're then asked to complete the tree diagram. Now, the important thing that we have to decide with any tree diagram is whether they're independent or not. Now, because we're not told anything here about the second penalty is affected by the first one, we can assume that the first outcome does not affect the second outcome. So we're going to say these two events are independent. Now this is important when we get a little bit later on, but essentially all that means is for every penalty kick, the probability he scores is the same and the probability he misses is the same. So the probability he scores is 0.6. And because we know that these probabilities in these two branches need to add to make 1, we therefore know this one needs to be 0.4. Now back to that point earlier, because we know they're independent, because it didn't say that there was anything to tell us they're not independent, every time he scores it's 0.6 and every time he misses is 0.4. 0.6 and 0.4. Now that will be enough to get you all the marks for completing the tree. However, I always recommend that you add a little bit to the end of this. On the end of your tree, on the end of each branch, what we're going to do is we're going to look at the combined outcomes. So for example, if we score and score, what we're going to do in this case is we're going to do 0.6 times 0.6, which is 0.36. For the second one, so following on the branches, score and then miss, that's 0.6 times 0.4, which is 0.24. The third one, miss and score, so miss and score, again 0.4 times 0.6 gives us 0.24 again, and those two in the middle are often the same, particularly when they're independent. And then finally the last one, miss, or missing both, is equal to 0.4 times 0.4, which is 0.16. Now, a way to check this for us is what we want to do is we want to look at all of these numbers we've just figured out here in the end. So this 0.36, 0.24, 0.24, 0.24, or 0.16. They should all add up to give us 1. Now in this case they do, so we know that we're correct. So it's a good exercise to check. But the main reason we do that is actually, if you look at our second question, it asks us to work out the probability that he scores both penalties. Now even if we don't know how to do this, we've already got some of the marks, because scoring both penalties is just score. So we've done the calculation up here, and all we have to do is then write down what was just 0.36. But even if this second question is more complex, just by having that on the end of the branch, you're likely to get 1 or 2 marks. Now looking at this second question, we're told bag A contains 6 red counters and 3 blue counters, and bag B contains 7 red and 8 green counters. Now because they're separate bags, we can straight away see that these are independent events. Okay, and they're independent, and we can see that because they're 2 different bags. Now in this case, we're given just the numbers here, so what we want to do is we want to figure out the probabilities. And the easiest thing to do is to use fractions. So the probability that is red is 6 red counters out of 9 in total, and the probability of blue is 3 blue counters out of 9 in total, because they're both for bag A. Now for bag B, like we have over here, it's 7 red out of 15 in total, and then there's going to be 8 green out of 15 in total. Now again, because they're independent, the important thing is actually that this set of branches here and this set of branches here are going to be the same. So this red is 7 over 15, and this green is 8 over 15. Once again, like we did before, we're going to work out our ends now. So red, and we're doing 6 over 9 multiplied by 7 over 15. Well, 6 sevens are 42, and 9 times 15 is 135. Again, if you don't know 9 times 15 in your head, you can just do it on the side. 15 times 9, 9 fives being 45, carry your 4, and then finish it off 135. The second one, red and green, 6 times 8, 6 eighths are 48, and again we're doing that 9 times 15, so 135 on the bottom. Third one, blue-red, is 7 times 3, or 3 times 7, which is 21, again over 135. And then finally blue-green, 3 times 8, which is 24, over 135. Now, if you use a calculator, it might simplify some of these for you. We don't really want them simplified, particularly when we're doing a non-calculator question, and we don't need to. But that's because we can then do our part B in a much easier way. So it says to calculate the probability that he selects at least one red counter. So it's any time he's selected a red counter. So we've got this one here, we've got this one here, or we've got this one here. So we're doing 42 over 135 plus 48 over 135 plus 21 over 135. And by not simplifying these, we can then just add all of our numerators together. And that gives us an answer of 111 over 135. Where if we'd simplified those, we would have had to have unsimplified to then get back to that. Again, that green on the end is really, really helpful because we get some of the marks without even figuring out that at least one red counter. Now, question 3 gives us a slight variation on this. It says a bag contains 7 orange sweets and 5 apple sweets. Tanya chooses a sweet at random and eats it. Harriet then chooses a sweet and eats it. Now the important thing here is that eats it. Because they eat the sweet, it means it's not replaced or not put back. So therefore the probability for Harriet will change based on the choice that Tanya has made. So therefore these are what we call dependent events. Okay, they're dependent events because depending on what happens for Tanya, it's going to change the probabilities for Harriet. So we'll look at Tanya first. So there are 7 orange sweets, and in total there are 12 sweets in the bag. For apple, it's 5 out of 12. So that's really straightforward for Tanya. Now for Harriet, what I like to do is I like to figure out the denominator first. Because Tanya has eaten a sweet, there's only 11 sweets left in any of these situations, because Tanya's already eaten one of the sweets. So all of these are out of 11. Harriet then, if Tanya has chosen an orange sweet, there's only going to be 6 orange sweets left. So therefore Harriet is 6 out of 11. But all of the apple are still there, so this will be 5 out of 11. Now if we do the bottom and we essentially restart, we come back to the starting point, and we assume Tanya chooses an apple sweet first, well then there's actually 7 orange left and 4 apple. Again, we can see that these two values here add to give us 11 out of 11, and we can also see that these two values here give 11 out of 11, which is what we would hope for. Okay, and that allows us to check that we're correct. So as we have done before, we're going to work at the end. So orange, orange, we're doing 7 over 12 times 6 over 11. Well, 6 sevens are 42, and 11 times 12 is 132. Okay, orange apple, 7 fives is 35, again out of that 132. Next one, apple orange, 7 fives again are 35 over 132. And then finally the bottom one, 5 times 4 is 20, so apple is 20 over 132. Again, checking our answer by adding up all those fractions on the end, it does give us 132 out of 132. Now looking at our part B question, it says calculate the probability they both ate the same flavour sweet. Well, that because we've got these labels here, it makes it easier for us, so we can see that it's orange orange or apple apple. So therefore the probability they ate the same sweet is 42 over 132 plus 20 over 132, which gives us 62 over 132. Apologies, 132 and 136. Now, we can simplify that, but we don't need to. The only time we don't need to simplify our fractions is when we're doing probability. So we can leave our answer as 62 over 132. Now our final question is slightly different. What you can see here, the difference between this tree diagram and the previous ones is it's not symmetrical. Okay, there's not 2 sets of branches for the second choice we have to make, and there's a reason for that. The important thing to remember is if we add in those branches and they're not supposed to be there, we can potentially lose marks. So we need to make sure we're reading the question very carefully. So it says a fair spinner is numbered 1, 2, 3, 4, and 5, and then a fair 8-sided dice has 3 blue faces and 5 purple faces. It says the spinner is spun. If it lands on an even number, you win. If it lands on an odd number, you then roll the dice, which is why we end up with branches here after odd and not after even, because after even, you just win. Then it says, if the dice lands on blue, you win, and if the dice lands on purple, you lose. Okay, so blue is a win, and purple is a loss. So we don't actually need to think odd blue, odd purple. We just think, well, that's a win, and that's a loss. So we lose here. So if we work out our probabilities then, so for the spinner, the probability it lands on even, well, there's 5 numbers on that spinner. So 5 is the denominator. 2 and 4 are the only even numbers, so that's 2 even and 3 odd. So 2 out of 5 do we get an even number, 3 out of 5 do we get an odd number. Then it says we roll the dice after we get an odd number. The probability of blue, well, there's 3 blue faces and it's an 8-sided dice, or 5 purple faces on an 8-sided dice. So therefore, that's our probability tree drawn. Now what we're going to do again is figure out our probabilities in the end. Now because there's only one branch here, the probability of winning here is just 2 over 5. The probability of winning here is we multiply our two fractions again. So we're looking this time again at our 3 over 5 times 3 over 8. And 3 over 5 times 3 over 8 gives us 9 over 40. And then to finish off, if we look at our last option, which is our 3 over 5 times 5 over 8. So 3 over 5 times 5 over 8 gives us 15 over 40. Now it asks us, it says, if you play the game, are you more likely to win or to lose? Well, the probability that we win is equal to 2 over 5 plus 9 over 40. Now with that one, again, when we add fractions, we have to have the same denominator. So 2 over 5, we can multiply that by 8 to give us 16 over 40 plus 9 over 40. That gives us 25 over 40. So the probability that we win is 25 over 40. The probability that we lose, well, there's only one way that we can lose, and that's getting an odd number in purple. So that's 15 over 40. So it says, are you more likely to win or to lose? Well, the probability of winning is higher than the probability of losing. So therefore, we're more likely to win. So the answer to the question is to win. Make sure we go back and we read that last part of the question to make sure we make the decision it asks us to do. It doesn't ask what the probability is. It asks, are we more likely to win or lose? But by saying we must show we're working, we have to get those two probabilities in a comparable form. So either both as decimals, both as fractions, with the same denominator, or both as percentages. As always, thanks for watching the video. I hope you found it useful and you were able to figure out those questions and get the support you needed for any you're unsure about, and I'll see you in the next video.